Okay, so remember alkanes undergo the free radical substitution. Got 3 steps, and the 3 steps always 1, 2, 3. Yeah, very clear. Try to understand so that anything also can. So first of all, ClCl. What is this word called? Again, what's the word called? UV light. What is that? Half break. Yes. Yes, homo, same. So homolytic fission means break equally. There are no ions, right? Got ions or not? No, because I never give the electron. It's just originally 7, 7, now 7, 7. Okay, each chlorine 7. So it's chlorine radical. Chlorine radical, very reactive. Chlorine radical is very reactive, right? So they cannot, so you must try to understand, must try to understand that it react propagation, right? Propagation. So the chlorine radicals cannot wait to react. They need to find an atom desperately, right? Wait a while. Right? They need to find an atom desperately, and then I need to decide that the chlorine there. So I will just draw a H here, but I don't need to draw H, but then I need to draw. So you must know that the chlorine radical will become a molecule. You must understand. Radical become molecule, molecule become radical. This is something that you can follow also. So this guy meets somewhere, half of it meets somewhere, and then because you break to that guy, no choice, right? So HCl hurry up from happy. Now another guy is sad. Who is sad now? Again, who is sad now? Who is sad? HCl or the radical sad? Don't know you understand my lingo. Who is sad? HCl or the radical? Okay, what's that? Who is that? The radical. I see, I teach you long enough. You can but reach a level you can read my mind. The radical is very sad. You know why? Why sad? It's so sad. Very sad. Why is it sad? It really, really, after student starting, they cannot read my mind. After hopefully, 2 months, time, can read my mind. This guy very sad. 7 only, walao, 7, 7. So sad, so sad. So how? Then no choice. I find the atom quickly. Right? Try to understand, then when you draw, you can remember. Right? So straight away, this guy come out already, right? Cl plus Cl dot. You think can tell me who set now? See, go copy it. And the chain reaction take place, right? Right? Okay, finish. Termination to draw, easy, right? Termination is very easy, right? Please try to understand. Termination, just don't careless, right? All the radicals will react lah. All the radicals will join together. Terminate what? As long as there are no more radicals, right? Reaction cannot take place. You must understand this very well. If not, problem again. Okay? So the toughest is the third equation that I'm trying to draw now. It's very tough because you must visualize how to link them together. Which, you know what I do? Okay, you're correct, but what I do is that I will do it like that. I select one, right? And then I will draw a line together like that. But even if you can get it, then get it lah. It's okay. But this is just easy way out, right? Just make sure they are positioned that way, then you can join together. So when there are no more radicals, reaction free radicals, substitution stop or propagation stop. Now, so this is of the, this one also exam to ask, lowest proportion, lowest proportion as this guy and this guy as it is formed via two intermediate. Because intermediate, because this is an intermediate form and I use stop. So these two are intermediates. Intermediates are very low proportion in the reaction. Understand? Okay, I say again, intermediates, you know what intermediates are not? First step I form, right? The dot. What I use again? So very little one, right? Unlike no, good question. Well, lucky you asked me this. Okay, anyway, this part, this label is this two brown one is intermediate. Okay, I better put properly because this one A level test, intermediate, right? Then A level also test before. What is a Cl dot? Yes, write down. You know why I call catalyst or not? Because I react, after that I reform, right? Then I react, I reform, I react, reform. Always have a lot on it. Means during the initiation, I just need little radical enough. Little. So at the start, Just a little, you like little radical. I think one, cannot one, a little bit. No, it's not only that you start. No. It's you start then form, not form, you start. You cannot see bottom, you see top. So you start then form. Okay. Okay. So which one? Very little. Again, catalyst or intermediate, very little. No, intermediate. Okay, one time, catalyst always a lot, you know why? I always have one. Intermediate little, you know why? I form my one nice, straight away I start. Push out a lot. Push little. Okay. Finish up. Also difficult. Okay, but look at it constantly, you forget one. Is it not? Okay, the next part of alkane, second two part only, and we are done. You see, 5-10 minutes, we are done. Right? The school can take 1-2 weeks. Now, the next part is just like that. It's just like that. The ratio, so spend much time. Okay, can you tell me how many product is it? How many moles of the product? They ask you same thing. I repeat my lesson, I just repeat my job. How many, Tiang? Then Ethan will say whether he's correct. Okay, sorry. How many different types of product will be formed? 5, is it correct? 5. What's the ratio? Tiang? Correct. 6 to 1 to 2 to 2 to 3, correct? From the left to right. Then you understand. Is it 6? You know why 6? 1, done. Correct, 6, Okay? Again, now I ask you. You say 6 to 1 to 2 to 2 to 3. Okay, fast one. 6 to 1, right? A few different colors. To 2, right? This is also different. To 2 and to 3. Now, let me ask you a question. Which one will form the fastest? Okay, which one is the largest proportion? Is the 6, Sub there, right? Which one will form the fastest? Again, which color is color coded, right? Which color that I sub there will form the fastest? I never say largest proportion, I say fastest. Yellow, yeah, I don't know right or wrong. Correct, because it's from the what? Tertiary radical, right? Most stable, right? Because most electron donating R groups stabilizing the radical answer. No, it's good alkyl. Tertiary radical, tertiary alkyl radical. I think both can. Understand? Yeah, maybe it's tertiary alkyl radical is fine. You can say that. So. Okay. Reading notes, don't spend much time, right? During tuition, you really read notes. Reading notes, you do the question at home, learn the answers. Do the question, important. Listen. After he suck, yay, suck in it. Look at this. Is that enantiomerism? After he sucked, the Cl went in. This product is that enantiomerism. Right. Enantiomerism, check for what? 4 different groups gone up. Do I have right? Do I have all? Okay, now. Correct, don't have. Now, hold on. After he sucked here, is there enantiomerism? Have I? Very good. Star here, right? Then draw the tetrahedral arrangement. You know how to do or not? Something here, something here, something here, and something here. Correct? Now, why sometimes there's a chiral center but no optical activity? This one I don't really write in the page, but just know why sometimes there's chiral center but no optical activity. The chiral center means got means it's optical active. That means can rotate light, but some don't have that. Why? Tell me, okay, one is racemic mixture. What's the meaning of racemic mixture again? Again? Of course, but what makes a racemic mixture? How come a racemic mixture will be produced? Again? Okay, your brain associate that. I mean, you're right, but because of 50% each, okay, one time, hello. So what is a racemic mixture? It sounds very confusing and sounds very like difficult. You know lah, it's just 50% of each enantiomer lah. Okay, how it formed, that's another issue. But for now, it's that. You understand? Right, so 50% rotate the light in an angle, at some angle, same angle, but the opposite direction, one clock, one anti-clock. Which one I also don't know. So racemic mixture consists of two enantiomers. So it's like a mirror image, you know, of the exact same thing. You understand? So it's a mirror image because they are enantiomers of each other, right? So I want, okay, like lazy to draw those things there, but the idea is that they are of equal proportion. But how it's formed, yeah, there's another issue, right? Like you say at the top and bottom, there's other chapters. So racemic mixture is one scenario that there is a chiral center, but not optically active. What's scenario number 2? Got chiral, but cannot rotate. There's one more scenario. There's a what? There's a plane of symmetry or there's a line of symmetry, right? Before not, means what? I show you this. OH, H, CH3. OH, H, CH3. Is that chiral center? How many? Then how many? 2. Wow, this one even scarier. Like 2, got 2 chiral center. But there's a plane of symmetry, right? So cannot rotate also, cannot rotate. I don't know the school teacher now. What is this thing called FRM? Yeah, some school teach, some school never. But this, I don't know whether it's in A level, but anyway, it's called a meso compound. Means have a plane of symmetry, cannot rotate. Okay, so 2 scenario again. So be careful. A level ask, there's a chiral, but why cannot explain? They'll tell you like that one. Okay, how it rotate, that's not, I also don't know lah. But the idea is that once there's chiral center, it should rotate. But sometimes racemic, they cancel out, or meso, maybe they cancel out also lah. I also don't know how it works, to be honest. Okay, but if the school never introduced the word meso compound, they just say there's a plane of symmetry or there's a line of symmetry. Faster. So please remember, more electronegative, can you put a delta minus delta plus? And because delta plus lacking electron, please try to understand, you attack, can point directly to the atom, right? And the first step is called slow, right? And then please don't anyhow and go luck, depends on luck, put in the first atom that enter. Who's the first atom that enter? I, the first atom that enter to the carbon in more H. So I put I here, so that there's a plus here. Why? Plus F minus. Okay, so this is called Markovnikov, right? What carbocation is that? Okay. Good. Tertiary carbocation, right? Which is very stable, right? So this is more stable because disperses the positive charge. Right? More electron. So got more electron donating alkyl groups that disperse the positive charge. Okay, organic compounds don't like charge, whether positive or negative. Okay, so very quickly, the next step come in, right? Okay, so naturally you will find the plus. I mean, it's a carbon there. Don't attack the plus. I know some people draw that way, but I think this is the best. Attack the carbon. Nice, finish. Easy, yeah. Okay, so please remember this is called Markovnikov for the choosing, right, of the major minor product and put in the first atom to the carbon in more H. Now, so I mentioned just now again, so the 4 variation only got 4 will be Bromine liquid in CCl4 or organic solvent, bromine aqueous. This one can put these two together in your head. So the only difference, bromine aqueous got what? Huh? Water means instead of the F will be the, instead of the second one is the water attack, right? So OH. Okay, right? Third one will be the dry HBr gas. Okay, all these are room temperature, by the way. Yeah? And the fourth one is your water, right? Addition of water, cold, concentrated, H2SO4, followed by boiling with water. Understand? Okay, very quickly, the next part, I know there's a lot of things, but at least the main part is your oxidation. Mild oxidation to easy one. Right, mild oxidation, you can remember the conditions? Okay, but say properly. Cold, then they say dilute NaOH, KMNO4, right? Okay, then what happened? It's just break like OH and OH. Okay. Okay, easy. Right, so this one here, maybe 10% chance appearing, but still need to know the main part is your strong oxidation. So strong oxidation. Okay, you try first, then I teach you. So try to draw out this guy here. I'm going to make it more complicated.
Is your mild oxidation is there acidic and basic?
Yeah, I actually also have. I saw before. Some school ignore, so there's also acidic, but the product still same, my friend. Okay, but some school, most of school put like that. Okay, now I show you something. Very scary. Okay, very scary. Strong oxidation, this guy, before I tell you. So is same thing got acidic, basic, but we do the acidic one first. So KMNO4, dilute, H2SO4, and heat. Can you draw the products before I go through? Then please hurry up, do this. Use a pencil, do this. Use a pencil, do this. Okay. Then very quickly, right? Like that. Double bond O. Like that. Very stressed. Double bond O down. What this guy very stressed. Double bond O. Okay, so I already secure that part there, right? You know this. You know which part I'm talking about now. So secure this part. Okay, so okay, I color code so it's very clear. So those that got H, OH. Feels weird, right? This one OH. Finish. Understand? Right? Double check, your own double check, don't tell us. Right? Then after that, maybe the yellow part, this one here, right? I put yellow, right? We'll get like that, double bond O, OH, OH. Hey, you must know that this guy doesn't exist. He will further oxidize to form 2CO2 and H2O. Hey, understand? What's the name of this guy? Ethane dioic acid, right? Because there are two acids and two carbon. Ethane. Must know, this guy and carbonic acid doesn't exist. Okay. And the last guy, which I should use your blue cannot. Purple, okay. So this purple part, right, will be who? It's just a one line, double bond OH. Finish. Okay. 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 So I sidetrack a bit. This guy also doesn't exist. I say first. Okay, so I mean it came from double bond O H H. And then so this guy will break down carbonic acid is unstable, CO2 and H2O. Do you understand? And then yeah, you did. Okay, so strong oxidation, just do this method, break and then try question. Break, put O, ethane diacid and carbonic acid. So this guy is called carbonic acid. Not carboxylic, carbonic acid. Okay, easy. More important. Okay, so Arenes undergo electrophilic sub because benzene is electron rich. So you must always know the guy that is connected here, right, is always like that one. This part here, the connection or the new connection is your electrophile, right? Which actually C-double-O plus CH2CH3. You always must know is like that, correct? So the first step is always called generation of electrophile. Generation of electrophile means, right, C double bond O, anything you like, right? Anything you like. Okay, then AlCl3, try to understand this guy. It's always termed to be called, they must be anhydrous by the way, anhydrous. Why, A level asked before, I think. Why wet cannot? Why hydrated cannot? Why got water cannot? Yes, because in the periodic table, you learn this guy will undergo hydrolysis, then gone. So this AlCl3 is what? It's a Lewis acid catalyst. Or sometimes his role, people call it halogen carrier. He carry the new halogen. So these are the terms that help you learn. So you carry AlCl4 minus. Okay, and Lewis acid because electron pair acceptor. AlCl3 is deficient. Then you get our electrophile, the main character. You don't get this, how to continue. Understand? Make the electrophile, right? Make the electrophile. Then now, different school, different. I will just use my layman term, attack electrophile, right? Okay, attack electrophile. So the benzene is electron rich. Okay, it will attack the plus, the carbon with the plus, electrophile, attack. Slow step, by the way. Okay, then 3 directing in the data booklet. So H and C double bond O, CH2, CH3, then point this way to a plus, correct? This is an unstable carbocation intermediate. Okay, because I cannot undergo resonance stabilization, my benzene restructure is disrupted already. Well, I cannot. So you need to understand this thing is happening. Then you can continue to say, okay, so regeneration of benzene aromaticity or benzene ring now, ring isochine, right? And this one different school different, but a safe that will be like that. So plus is being deprived. Okay, so the plus is being deprived. I return the electron fast. Okay, plus AlCl4 minus. Is it this one I use? Yes. Yes. So I get back my catalyst. Hurry up. So actually this one also regenerate catalyst. Okay, a byproduct HCl and like that. Nice. So his benzene ring is regenerated. Yes, and thank you very much. Can you write down the variation now? Let's carry now. First one is what we just gone through. It's called acylation, right? Anhydrous, AlCl3, right? Feeder class, alkylation, right? There's 2, right? Is like that. Okay, I know it's very difficult, but hold on, same. So acylation means there's a COCl, then there is a, I draw anything like, H, right? Alkylation is a CCl, it's just alkyl group going on. You know what's the difference? Alkyl group means there's no CO. Acyl group got a COCl. So eventually, both of them, the Cl will disappear and put a plus. You didn't understand? Acylation, yes. So this called, first one is called Friedel. Is it correct? Crafts acylation, because COCl is an acyl group, right? Then the second one is called Friedel Crafts alkylation, because an alkyl group. So alkyl group is the CC. Okay, for this case, right? Later you put a plus here, but plus. Do you understand? You see? Still got what? Halogenation, right? Halogenation, but the same feeling. Cl2 anhydrous AlCl3. So all the AL solution can be can be a lot, can be AlCl3, AlBr3, FeCl3, FeBr3. Normally you can choose either one. It's the same thing. And all these three room temperature also. So far. Right? RTP, room temperature pressure. Last one is what? Ethane, can remember? Nitration, very good. So nitration. So this one bit tough, concentrated nitric acid, concentrated H2SO4 and 55 degrees Celsius or 60 up to. Okay, so you must know like alkene got 4 variation, arene also got 4. Okay lah, not too bad. Okay, you must know all the variation, not only the mechanism.